Okay, we'll go ahead and get started. I'm not sure if the viewer count is actually accurate on here or not. Technology. Okay. So thank you to whoever's watching this, whether it be live or after the fact on YouTube here. Very excited to be able to give this presentation. The build environment is sane. I'm pondering this phrase that has appeared on my computer screen. I'm building some software from code on my Linux machine, and I'm pondering the importance of sanity tests in computer programming. They allow us to ensure that there's no massive logical or mathematical errors that could cause some drastic problem to occur with the computer. It's a pity we don't have any of those for the programmers, however, because I can say from experience, the build environment is completely insane. There's a lot of unique personalities in the programming world and even beyond in the various other STEM fields, and I've even had people tell me this flows over into the arts. And social skills are vital, but being a young programmer, when I first started documenting this stuff, I didn't realize that the social skills in question were not the ones I was familiar with growing up. So today I'm going to share with you the array of weird personalities I've encountered in the world of computer programming, 3 habits to break that are critical to succeeding in this field, and how to maintain a connection to the real world. As I mentioned, the hard skills are only half of the picture. Those programming skills, the languages and the platforms and the computing skills. The other half are the communication skills and the social skills, better known as collectively as the soft skills necessary to succeed. And I learned most of these the hard way. I really don't recommend it. It's not a lot of fun. The sooner you learn these, the better. And even if you've been in the field for a very long time, you still have the opportunity to master some things maybe you didn't pick up earlier on. It's never too late. Now, as I mentioned, I made a lot of these observations myself in the course of learning how to program, learning how to interact in this field, and through my experiences as the CEO and lead developer at MousePaw Games. But I'm not the first person to make these observations. I found similar sentiments echoed in Dreaming in Code by Scott Rosenberg, which is a fantastic read, by the way. Eric S. Raymond's Cathedral and the Bazaar and the New Hacker's Dictionary also make similar observations. And I've seen things along these lines said by Jeff Atwood, a respected programmer, one of the founders of StackOverflow, and a blogger at codinghorror.com. Fantastic blog, by the way. I like how Joel Spolsky put it. He's one of the co-founders of StackOverflow. He said the difference between a tolerable programmer and a great programmer is not how many programming languages they know, and it's not whether they prefer Python or Java. It's whether they can communicate their ideas. Communication is key in this field, and actually it's key in nearly any field. A lot of my experiences come from my time interacting on StackOverflow.com, which is an excellent resource for programmers. If you're in IT, I recommend checking out their sister site, ServerFault. That's also a very helpful resource. I've also interacted on a number of forums and IRC channels for programmers, some good, some not so good, and I've seen the same patterns repeating. But honestly, the skills I'm about to discuss apply everywhere, all over the place, all over the map. So a bit of a warning before I go into this, do keep in mind, always follow the rules of whatever community you are in, whether it be on the Stack Exchange network, a forum, an IRC channel, or an in-person discussion. In short, you should be professional at all times. It can be very hard for a greenhorn to get accepted in this field, and that's true whether you have a degree or not. Programmers in general don't have much regard for degrees so much as for experience. They want to see what someone has actually built. And in general, a lot of nerds don't like newbies. They don't like non-technically minded people in general. At the same time, however, a lot of programmers actually I'd say most, harbor this internal self-doubt of, am I a real programmer? I've learned pretty quickly, don't ask that question. If you've written a single line of code in your life, you are, by definition, a real programmer. You've done it. That said, you can always gain skills in programming. You are a real programmer from the first line of code you enter, but you are not an experienced programmer yet. You gain experience over time, but don't ever let anyone talk you out of the fact that you are a real programmer. And everyone has these doubts. Like I said, even some of the great programmers wonder, am I a real programmer? And the answer is yes, you are. As I said, I've been cataloging these species for a few years, but I like how Eric, as Raymond puts it in the New Hacker's Dictionary, he said programmers generally aren't much like other people. They tend towards intellectual arrogance, self-absorption, and impatience with people and tasks perceived to be wasting their time. How true it is. So the first species I want to discuss is Programmaticus nubiflamoris, or the newbie flamer. This species will attack over anything that they deem to be obvious, if only to them, incorrect, or otherwise newbie in nature. And they do so by tearing down their victims' intelligence, professional status, project viability, and the like. All while nimbly avoiding giving anything that even resembles an answer. They're very good at this. I've learned that the easiest way to handle this species is to lay as still as possible. In a word, keep my mouth shut. There's two benefits to this. One is that it earns you experience points because you didn't engage with the trolls. But two is that trolls in general like fighting. They enjoy it. That's why they do it. So by not engaging with them, you kind of deprive them of the thrill of the hunt, and hopefully they'll go skulk off into the distance. The attack also generally attracts the nicer, stronger species, i.e. moderators and more experienced programmers who can do the fighting for you. If you are a much more experienced programmer and you know for a fact that you have more precedence in the community than the troll in question, you can try and take them on. But in general, arguing with them is a waste of time. They're not there to learn. They're there to force their stupidity down everyone's throats. So when it comes to Programmaticus nubiflamoris, using the approach of just flagging them, kicking them off if you have the privilege, and just moving on is usually the best approach. Just got a question over here on the side, actually, I'll quickly address, which is, are these real terms? And okay, I made these up, these species names. I've long time been a fan of Looney Tunes, and I always liked how they put these at the beginning of the Roadrunner cartoons. So these are made up, but the personalities behind them are definitely very, very real. Okay, so I'll have a lot more time for Q&A. If I see one that I want to snag right now, I'll answer it, but I'll leave a lot of these towards the end here. Now, many incidents of attack are actually partially the responsibility of the one getting attacked, because it can be very easy to look like this species' prey. Programmaticus nobugulus. This species is considered parasitic, blob-like, and invasive, and they are a major cornerstone of the downfall of many a programming community, because they ask questions with the sole intent of avoiding doing their own research, if not actually avoiding writing any of their own code at all. We summarize their whole attitude in the phrase, give me the codes. Typos are actually intentional there. Again, nobugulus basically does not want to do the work themselves. They're copy and paste programmers. And the problem with being a copy and paste programmer is that you learn very, very little that way. The common violations cited against Programmaticus nobugulus include RTD, sometimes abbreviated RTFD by the less friendly species. which means read the documentation. The documentation is your single best source of information for any technology you're using, whether it be a program or a piece of software. That's what I just said, actually. A programming language, a toolkit, whatever it is you're using. The documentation is the first place you should go for information about it. The problem is that the documentation is thick, dry, boring, and very much like eating a giant hunk of toast without any butter. It's not very pleasant at all. But the thing is, you don't gain the skills to read the documentation just over time. It's something you have to build by reading the documentation. It's challenging. There's a lot of terminology that at any experience level that you will encounter that doesn't make sense. So look things up as you go along. I actually horked down a 15-page white paper on benchmarking on Intel processors. That was an interesting 2-day experience, but I wrote some very good code coming out of it, and I learned a lot about assembly and a lot about benchmarking in general. So even though it took a lot of effort to read that documentation, I learned a lot out of it as well. So read the documentation. That's your first place to look. The second violation is, let me Google that for you, often abbreviated LMGTFY. This is an actual website, by the way. You should spend at least 30 minutes researching your question before asking it on a programming community. Now, I keep mentioning Google, but I have to admit my favorite search engine is DuckDuckGo.com. I find that they typically have a lot more relevant search results for most things, programming especially. But whatever search engine you use, you should spend some serious time trying to find the solution yourself. And then you need to experiment, or what have you tried, according to programmer and blogger Matt Gemmell. You need to assume that you're going to write most of the code yourself. So by taking the time to experiment with it, use the knowledge you currently have and the fruits of your own research to try and solve the solution yourself. First of all, it stretches you as a programmer. Second, it tells us what ground you've covered by the time you come ask us the question. We're not going to give you a solution that you already have tried because we know it didn't work. It leads us more towards the solution you're looking for if we know what ground you've covered. It has a side benefit, too, of proving you're not a no-Google-list, because no-Google-lists, again, they just want the code. And give me the codes is pretty widely resented. All that said, you should not confuse give me the codes with the good practice of rewriting existing code for your own purposes. As the adage goes, good programmers know what to write. Great programmers know what to rewrite and reuse. A couple other things. One, students, beware of asking about homework. Asking homework questions on Stack Overflow is pretty dangerous territory, because first of all, you are already pretty well equipped to answer the question yourself by your educator. If your professor has given you an assignment, or your teacher, or the book you're following, they've given you all the knowledge you need in general to solve it, or at least the skills to research it. Besides that point, chances are you're covering some pretty elementary ground. So through a little bit of online research, you should be able to find the answer pretty quickly. It's not so novel that you would need to go ask for help in most cases. If you do need to ask for help, because once in a while it just doesn't click, or we can't solve it, just doesn't make sense, and we're really desperate, when you do ask for help, only ask for the logic. Never ask for the code. Please, for the love of all things digital, do not ask for the code, because we can spot a homework question from a mile away. I actually dubbed September Stack Overflow September because of this. It's amazing the number of people coming in looking for code to be handed to them for their homework assignments. So ask for the logic to be explained so that you can write the code yourself. Otherwise, you're circumventing the entire learning process. And I'll get to that again in a minute. Finally, grammar and spelling is really important if you want to avoid looking like a no-Googlist. It isn't a coincidence that there's misspellings and typos in the phrase "give me the codes." No Googlist very commonly has a poor grasp of the English language or whatever their native language is. And I want to say that if English is a second language for you, we're pretty patient in the programming world for that. We'll help you clean up the grammar. But if it's your first language and you don't have a good grasp on it, you're going to have a hard time getting respected because we equate bad English with bad code. It's not really all that illogical either. English has its rules. It has its grammar, its syntax, its spelling that has to be followed in order for you to express the idea. But the rules of English are somewhat flexible. Code, on the other hand, has rules, syntax, grammar, spelling that has to be followed perfectly at all times, otherwise weird things happen. So we make the assumption that if English, which is flexible, is difficult for someone, then code, which is inflexible, is going to be darn near impossible. And side hint, don't ever call a programmer or any other nerd a grammar Nazi, because we are. I have seen more pedantic corrections to grammar on StackOverflow than anywhere else except maybe the grammar nerd forums, because we've trained our eyes to recognize little errors. That we've done that in the code, and so we do it in English as well. And as I'll mention again later, all great programmers are also great writers. It comes with the territory. You may be thinking right about now, okay, this sounds like programming is a pretty brutal and elitist industry. Well, you're right, it is. The good news is that the greenhorn of today is the expert of tomorrow. It is in our power to change this climate. In order to change the climate, however, we have to understand it and survive it. The species that you want to find and eventually become, the species that wants to change this climate, is Programmaticus mentorius. This species really enjoys helping others, especially newbies. They enjoy answering questions, and they have a symbiotic relationship with the greenhorn. They are well-armed, capable of defending themselves and others against attack in many cases. Part of this is because most mentorius have considerable experience, so they can take on the typically less experienced hostile species. All the same, few will attack the species more likely than not, because doing so causes the community to rise as one and beat the attacker senseless. But as I said, they can hold their own in a fight. Their patience is not unlimited, however. A mentorius has no more like for a no-Googlist than the next guy. A true mentorius will always require you to put in some effort to solve your problem. And that's an important distinction that I'll make in a minute. If you're fortunate enough to meet a mentorius, first of all, you need to respect their time and experience. They don't have to help you. And on a side note here, keep in mind they're also answering everyone who's going to find that conversation, or if it's in person, everyone in present company, not just you. Because they want to help the community grow. So they're going to put in a lot of detail, sometimes more than you might think necessary. Some of it makes sense. They don't know you from Adam anyway, so they don't know what you already know, but they're helping everyone else who will find the answer later. So don't ever complain to a mentorius about the level of detail they're putting into the answer. Thank them for it. Secondarily, don't deprive them of their food source, which is appreciation. Thank them for their time. Give them an upvote if you're on StackOverflow or a similar community. But keep in mind that they're not your new best friend. They don't want to join your Minecraft server. They do not want to go to the bar after work. And they do not want to watch a marathon of Star Trek The Next Generation with you. They're simply there to help you along in your professional development. The best way you can thank them is to actually give back to the community as a whole. Mentorius are always trying to build the programming community and make it a friendlier, more knowledgeable place. So helping this along by answering other people's questions is a great way to give back. You should always look to give as much as you take out of any community you're in. Easily mistaken for the Programmaticus mentorius is its less beneficial counterpart, Programmaticus enablicus. This species is very nice. They're very well-meaning. They do mean well, but they are misguided because they are acting as enablers for lazy programmers. They will literally give the code to the parasitic no-Googleists. They've been known to give code for homework answers. This is part of the reason why we have so many students showing up in September and January on StackOverflow asking for help with their homework, or asking for their homework to be done for them, is because this species will do it for them. Inadvertently, they're actually harming those that they're trying to help because they're circumventing the entire learning process. In the process of writing code or doing anything technical, you have to understand the logic that is going on in order to do the work you have to do. Enablicus is short-circuiting this entire process by instead just giving the completed work, instead of giving the instructions by which the work can be done. So if you encounter an enablicus, you need to have the self-discipline to not take the easy route. Don't take the code that they just handed you on a silver platter. Otherwise, you can easily become a Programmaticus no-Googleist. It is a short trip into that state, trust me. Ask for the logic to be explained instead of the code to be given. You can create the code using the logic, but the other benefit of the logic is that it applies not just to your specific situation, but to a far wider range of situations. It can be applied to many different scenarios by you and other people reading the conversation. Asking for a method also helps ward off newbie flamers because you're obviously not a no-Googleist if you want the method and not the code. You're not asking them to give you the code. You're trying to avoid it. Again, don't enable their enabling. Don't take the code and run. Be very polite with them because they do mean well, but make it clear you want to learn. Ask them to share the code. Don't upvote or accept if it's, or ask them to share the logic, excuse me. Don't upvote or accept their answer if it's code only, because that only fuels the habit. Instead, reward any mentorius that comes along and gives you a good answer. This sets a precedence for the enablicus to see this is a good answer, explaining the logic, not the code. Another false counterpart to the mentorius is the Programmaticus take-it-overcus. This species will attempt to take over your project from the other side of the room, city, state, country, world, without actually having any understanding of what your project is or does. I encountered this species when I was working on a very early prototype of my game. And I was experimenting with using video as the means of playing animations in the background and then putting the elements that the player clicks on top of that. A pretty common game setup. In general, have the animation and then the objects. So I described my problem. I was having some difficulty putting objects on top of a video. And I got the following response. Well, why would you want to put objects on top of the video? That would just look confusing. So I explained I was making a game. And he went on to tell me I was doing the wrong approach, the wrong style, the wrong method, the wrong language, the wrong toolkit, the wrong everything, knowing absolutely nothing about my project. I gave up trying to explain it to him because he was very much closed. The take-it-overcus will basically try to force you to adopt their personal methods while ignoring what your project actually needs. An important distinction that'll come up again in a minute is that they still debate ideas. They don't tear down people in general. They debate ideas. That's very important here in a minute. So if you encounter a take-it-overcus, as frustrating as that can be, you need to ask them to explain their approach. You can actually learn quite a lot from a take-it-overcus, believe it or not. Even if their solution isn't immediately applicable to your problem right now, you can still learn something. And then do some research on your own. See if their approach might work for you. If it won't, thank him either way. And then if it's not going to work, consider explaining why, respectfully. Ignore all further protests and corrections and don't call them out because they will be closed. Now, another important distinction, bear in mind that it's easy to mistake a mentorius for take it over kiss. But here's the difference. A mentorius will acknowledge your project's needs and the method that you took and then help you amend the logic that you followed in making the decision you did for your method, thereby helping you understand why you should go in this direction. Take it over kiss will do no such thing. They just want you to do it their way, end of story. So as annoying as that species is, its cousin is far scarier. Meet Programmaticus militaricus. This species will attack as soon as they encounter any use, promotion, or even the slightest hint of a method or a practice other than what they believe should be done. See, in the programming world, there is such a thing as good practice. You should understand what good practice is. You should know it. You should adhere to it until you have a very good reason to depart from it. But programming is an art form, and there are many cases where you will need to do something very different than what everyone else does. There's 100 good ways to solve things in computer programming. So with that in mind, good practice is a guideline, not a rule book. Mythical best practice is this idea that, okay, there's a set way to do things and it should always be adhered to. And this is what Militaricus believes in. Now, yes, there are debates about good practice among all programmers. These are very productive, although they get so heated, they're actually dubbed holy wars in Eric Raymond's New Hacker's Dictionary. But most programmers understand that there's need to be flexible, to try different things for different projects. Militaricus believes that best practice exists, it's martial law, and they're the marshal. They share the attack traits of Programmaticus nubiflamerus, although the difference is that they attack rather like a chihuahua. They will take on species much larger and more experienced than themselves. One example of this, I was in a chat room discussing practice in one situation, and someone disagreed with the way I was doing something. So I cited Donald Knuth. Now, Donald Knuth is legendary in the world of programming. He is professor emeritus at Stanford University. He's got, if memory serves me, 30 plus years under his belt. He's a master mathematician. He's written 4 volumes of algorithms that are still used today. His books, The Art of Computer Programming. So I cite Donald Knuth's statement regarding the practice I was advocating. And this guy responds to me and says, well, Donald Knuth is so old he couldn't code in C++ to save his life. Okay. So I cited Richard Gabriel, distinguished engineer at Sun Microsystems. Again, someone with a lot of experience. And this guy came back and said, well, Richard Gabriel is an idiot. Every experienced programmer I brought up, he would tear down their intelligence. Militaricus is unable to make a logical argument for their point of view. They can only attack people. They do not have the skills to debate ideas. And this is the distinction between Militaricus and Take-It-Overicus. Obviously, with that kind of attack method, it leaves the weaker prey stunned and questioning their qualifications. So how do you handle an attack from a Militaricus? Well, first of all, you actually need to ask them to detail an alternative approach. Have them make a logical argument for their point of view. If they can't, ignore everything they have to say. They have absolutely nothing to contribute to the conversation. They're a troll looking for blind adoption of their methods without any reason thereof. So don't feed the trolls. Don't attack them. Don't get into an argument. That's why they're there. They enjoy arguing. So write them off. Call the moderator's attention to it if you need to. And little hint, as in the case of the chat room I was in, if the moderator backs up the troll, bail. It's not worth sticking around. One of the more well-meaning species, but still problematic, is Programmaticus trendicus. This species demonstrates a lemming-like attraction to new technology, adopting new ideas and new tools and technologies as quickly as they show up. And when fully grown, they also become early abandoners, flitting from one mayfly technology to the next. They believe anything that they deem as old, whether it be C or C++ or assembly, should never be used, taught, or learned under any circumstances. They are also, in many cases, overly reliant on syntactic sugar. And syntactic sugar is a real term. It refers to the features of many modern languages that make it easier to write code. Funny thing is about many trendicus is that if you were to hand them a basic language like C++ and a text editor, they wouldn't know what to do with themselves. They wouldn't be able to do it because they've become reliant upon the modern helps, and they have lost many of the strengths that more experienced programmers have. Ironically, they will tell others not to reinvent the wheel. They can't imagine why we would need to do things a new way. Just use the trendy library, they would say. Some of this stuff may sound like good advice, but here's the problems. First of all, the car does not replace the engine. And in the same way, Python and Java do not replace C and C++ in assembly. They were built on C and assembly. So in order to be a master of that car, we need to understand the engine. In order to be a master of Python and Java, we really should understand the language upon which it's built and what's going on in the background. We need both. And the second problem is that software is not modular. It's not a bunch of Lego bricks that we can just snap together. Each piece has to be hand-tailored for a specific purpose. If it were modular, we could take the source code for, say, LibreOffice, rearrange it, and make something completely different without writing any new code. But it doesn't work that way. We have to write new code. We have to write code for each thing we're doing. This is an art, not a science. We also need to know when to reinvent the wheel. Now, think about the wheel for a second. The wheel has been reinvented many times in its history since our ancestors first chiseled it out of stone and made the first Fred Flintstone car. We have bike wheels. We have moon lander wheels. We've got car wheels and airplane landing gear wheels and gears and so many different kinds of wheels, each one reinvented for a specific purpose. So if we're doing something that's been done a million times before, like building a bike, we just use a bike wheel because the design is tried, tested, and true. In programming, if we needed to show an image on the screen, there's hundreds of libraries that can do that very well. But if we're building a flying car, we have to reinvent the wheel because we have to create a wheel that can handle the new stresses that'll be placed on it. Similarly, in code, if we're creating something that hasn't been done before, like my company's animation system, we have to completely rethink how we're doing it. We have to reinvent the wheel. We need to know when to use the existing design and when to come up with something new. Lastly, Programmaticus trendicus does not tend to read about their own discipline. And I'm not just talking about documentation. I'm talking about articles discussing theory and practice in programming. I highly recommend the writings of Matt Gemmell and Jeff Atwood and Eric Raymond and Scott Rosenberg. They're all fantastic authors. You see my bookshelves over here. I've got some of my tech books here. See that way. There we go. So I got some of my tech books there, and then up above, I have some of my fiction. For example, I've got Douglas Adams' Hitchhiker's Guide to the Galaxy up there too. Actually, reading in general is a really good idea. So with Programmaticus trendicus, keep in mind that they really do generally mean well. They usually will not attack unless they're a hybrid with one of the more hostile species, in which case see the notes for dealing with them. If they're well-meaning and you have sufficient experience, you can attempt to respectfully educate them on where they went wrong. But don't get involved in arguments because they're usually pretty stubborn and set in their ways. So don't argue it. You can have a discussion with them, but when things start getting heated, just agree to disagree and bow out. The last species is not at all dangerous, thankfully, unless perhaps given moderator tools. Programmaticus noreticus is trying to be funny or helpful, rarely succeeds at either because it doesn't actually read the question before answering. There was an example of this I encountered. I was working with a database system called SQLite, and I needed to know how to do something in it. So I posted my question, went into detail, what I tried, all this stuff, and I received the following answer in full verbatim. You use SQLite. Thank you. I had no idea. The person had not read my question. I didn't actually say anything in response because, don't feed the trolls. Yeah. So you have the chance to choose your path, and this is true whether you're just starting out or whether you're very experienced. It's not too late to change which species you are becoming. Never forget your beginnings, something that has been long since forgotten by Programmaticus nubiflamerus. Respect other people's boundaries, knowing that their projects are their projects. Something that escapes Programmaticus takeovericus. Hold your best practices with humility, unlike Programmaticus militaricus. Keep everything in perspective. Programmaticus trendicus long ago lost perspective. Be independent. Take risks, lest you become blobby and slug-like Programmaticus no Googleus. And look to give back, reading the question and looking to teach, to educate, unlike Enablicus. That's how you become the best species of all, Programmaticus mentorius. So if you recognize yourself among any of the hostile species up there, take heart. You can choose a new path. So aside from the hostile mobs to avoid, there are a few traps that await you out here. There's 3 common habits I see among programmers, especially young programmers, that I've seen lead to absolutely nothing but trouble. And I've had to break these in myself and in a lot of the people that I bring on as interns. It's just, these are pretty common habits. So if you spot any here, don't be too hard on yourself. Just learn from it. The first one is the shiny object trap, also known as, new technology. Programmaticus trendicus falls into this one a lot. Be careful of early adoption of new technology. It's great to experiment, try the new things out, but be careful of doing serious production work on them because they still have bugs. And those bugs can migrate to your project, have children, open a community center, and guess who gets blamed for that? You do. The user really doesn't care why the bugs are there. You picked the platform, so it must be your fault. The easiest way to avoid this trap is to wait for stability in software before doing development on it. If it says alpha or beta, it's not done. An example of this was HTML5 a few years back, which when it first was announced, all the web developers were going nuts. This is the holy grail of programming. This is going to do everything. And they tried doing everything with it, not just websites, but web apps and actual physical install on your computer programs and animation and all this stuff, and they couldn't figure out why stuff wasn't working right. It's because, first of all, it wasn't done. The W3 consortium, the people in charge of HTML, were saying, hey, yo, dudes, this is in alpha. Wait for stability. It finally was officially adopted towards the end of 2015, if memory serves. And now we're beginning to realize that some of those fancy features aren't capable of quite what we thought. So wait for everything to settle out before doing serious development work. Experimentation is great, but don't go nuts on new platforms. When it comes to hardware, you should wait about 1 to 2 years after its official release, in my estimation, before doing any serious hard programming on it. Again, you can experiment with it, but an example would be Google Glass. A lot of programmers built apps for the Google Glass. They put a lot of time into it, and then Google scrapped the project and decided to completely rethink it, which means we're going to have to go back to the drawing board on a lot of stuff. So waiting for a platform to actually become stable before doing serious work on it is generally advisable. If we absolutely have to develop for an unstable platform, maybe you've been hired to work on one of them, or you just are itching to try it out, wait until the platform is stable before you release your project, or in the very least declare your own project as in alpha or beta, so that the users know it's going to have bugs. Second trap is known as the Bermuda Triangle of quality, also known as high quality, on budget, and on time. I actually got that in a marketing phrase from an overseas programming firm, and I immediately chucked it in spam because that's not possible. The phrase is, I can make it quality, faster, and expensive, pick two. And they really do mean it. You have to pick two. Because if you attempt to do all three of these things at once, you're going to wind up over budget, bug-ridden, and or overdue, and your project vanishes in a puff of vaporware. A good example of this would have been somewhere around the turn of the century. So this would be in the early, mid-2000s. The people at Microsoft announced Windows Longhorn, and it was going to be this great, grand operating system that was supposed to change the world. Don't you love that phrase? They had said it's going to have all these new features. It's going to be faster. It's going to be more efficient. It's going to be capable of sharing with other computers really nicely. Great new file system. Fantastic operating system, they said. Well, it eventually got published 3 years overdue with a fraction of the features anticipated, and is now permanently cemented in the annals of computer science history as Windows Vista, largely considered one of the worst versions of Windows to ever hit the market. That was a case of trying to do all three at once. Once again, if you wind up in this trap, the client does not care. They may have asked for the impossible, but you promised it. So the client's not going to take the blame here. To get loose, you're going to have to admit your mistake immediately. Break the bad news to the client or to your users or to yourself that you can't do all three, and then pick two. Seriously, it's a sliding scale. So you can do a little more of one and a little less of the other. You want some extra features, you're going to need some extra time. Don't have extra time, you're going to need some extra money to hire more people. That gets into some weird stuff there, by the way. Adding people to a project, look at Brooks' Law. That's all I'll say on that topic. The third and final trap I'd like to discuss is the confusion snare, also known as, I'll remember what this does later. We get into a flow and we neglect to comment or document our code or have consistent style throughout the code, and we wind up trapping ourselves and others because we don't know what the code does. We can't remember. It's amazing. You can write code, come back a day later, and completely not remember what you were doing. And you waste coding time trying to get out of this trap. It also leaves you vulnerable because you can't defend a practice that you don't understand. You don't even know what your practice is, so how can you defend it? The best way to avoid this trap is just avoid it by commenting, showing the intent and logic. At my company, we have a standard called CSI, commenting, showing intent. Every logical statement in the code is accompanied with a comment that describes why that code is there and why we did it that way. It may sound like a lot of extra typing, and when it comes down to numbers, it really is. We got twice the code in there. But it saves us a ton of time because we can find errors and bugs more quickly. We can figure out what we were doing more quickly, and other people can read and understand the code considerably faster than if we hadn't commented anything at all. Be careful not to just reiterate your code. You should describe why the code is there, not just what it's doing. You also need to write the documentation. Oops. If your code can make fireworks show up on the screen, that's great. But you need to write the instructions for how to make those fireworks show up on the screen. Otherwise, the user is just going to try fiddling around, not be able to figure out why there's flying toasters on the screen instead, and then just stop using your software because it's too hard to use. And the same goes for coding libraries, by the way. Oh, Lord, I've seen some bad ones. Also, write descriptive names for all your variables, your functions, all the different parts of your code or your project. You need to have very good names because please, for the love of all things digital, do not use one-letter variables. The possible exception being I, because that's used typically for loop iterators. But beyond that, if you have variables A, B, C, D, X, Y, Z, and you're storing A into B and adding that to C and then getting input into D and combining that into X and printing out Y, E, I, O, you are not going to remember what that does later. So give your variables very good names that describe why they're there. And by the way, if you're in IT working in any branch of that field, it can be a little hard to write comments, but you can still document and you can still make notes of what you're doing as you go along, because trust me, there is nothing more annoying than trying to remember what steps you followed to set up a server. Comment and document. So it can be really easy to get sucked into this world of programming and completely lose touch with reality. Have you ever used a piece of software and thought, this is needlessly complicated? Or have you ever called tech support and received something that sounded vaguely like Klingon? This is all coming from a condition I like to call nerditis, which is an inflammation of one's technical abilities to the detriment of all else. Hostels are especially prone to this because they have a general disdain for newbies to begin with. But as I said, that's pretty common among many programmers. They don't like newbies and they don't like non-techs. This is where we get terms like ID 10 Tango errors or picnic errors, problem in chair, not in computer. Even Programmaticus Mentorius is at risk because they mean well, but they've spent so much time immersed in the computer world, they can no longer say it in English. One of my employees mentioned that he was talking to a friend, and his friend talked about some code he had written in these really flowery technical terms. And my employee responds to him and says, so you mean you did this? And he reiterates it in plain English. And his buddy goes, yeah, that's exactly. Which leads me to question, why do we use the flowery language to begin with? I think by and large it's because it makes us feel kind of important. So to prevent getting nerditis, first of all, ditch the lingo. Use analogies whenever possible. Yes, lingo can be helpful in some cases, but for the most part, speak in plain English. Why do you think that on the computer it's called a folder, file, desktop, window, button? It's because these are things we already know how to use in real life, and so they're analogous to how we use them on the computer. We can draw an analogy between the two, making it easier to understand. Second, have non-technical activities. And by the way, video games do not count. Get off the computer, get away from it, get out into nature, get around other people, interact around something that has absolutely nothing to do with technology. Third, remember what it's like to be a newbie. This will give you empathy for other people. When they're lost and they're scared to press the power button on their laptop, you can remember that once upon a time you weren't too certain either. And keep in mind that we're not superior because we can tame computers. Knowledge does not equal worth. And if you're taking notes, write that one down. Knowledge does not equal worth. The guy who can code instructions to land a rocket on an asteroid in binary on his toaster is not superior to the guy next door who's afraid to even turn on his computer. Knowledge does not equal worth. Avoiding nerditis does have additional benefits, including the fact that you can explain to non-technical people, such as coworkers who aren't programmers, maybe grandma if she wants to figure out how to check her email. You can communicate with users and clients better, understanding their needs. And then you can create software that just works for the average person. It just makes sense to them. User-centric design. So our Safari has reached its end, and we've covered a lot of ground, so let me take a moment to recap. There are a lot of strange personalities in this field, and you have the opportunity to decide who you are going to be. There's also a lot of traps out there, so watch what habits you allow to let form, because they can really trip you up later. And make sure you maintain a connection to the real world. Never check out of the human experience. We're humans first, programmers second. Or maybe third or fourth. Most importantly, don't take yourself too seriously. This hit home for me a couple of years ago when I was working on the game. And we have the user file where it stores all of the user's progress, their scores, their location, what items they found in the game. And to make sure that the user doesn't cheat, we were encrypting this down by using some code to take all of this information and turn it into this little 30, 40 character string of letters and numbers called a checksum. So when we open the file up later, we can make a new checksum, compare it to the old checksum, and if they match, the file has not changed. If it does not match, then something has been changed. And I thought, well, what happens if someone does change the file? Wouldn't it be cool if we could go back and we could recreate the file using that checksum just by trying all the possible combinations? Well, I was about to learn why it's called a one-way encryption. I used a little program I built to put in all the possible combinations, and I pressed the button to see how many combinations I'd wind up with. And walked away, came back 20 minutes later, and it's still calculating, and I'm beginning to wonder just how long this is going to take. So I pulled out my trusty TI-89 calculator and determined with mathematical certainty it would finish on June 26, 3598 at 8:42 a.m. I came to a logical conclusion at this moment. This was not a viable piece of software. Okay. So I see I got a question on the side, and if anyone else has any other questions, you can put it over on the question box on the side there, and I will do my best to answer it. If you're watching this after the fact and you would like me to answer a question for you, I would actually be stoked to do so. You can contact me at jcmcdonald@mousepawgames.com, which I'll put that in the description. So, question I have here right now is there a difference between reinventing and modifying? Going back to my discussion with Programmaticus Trendicus. I think there may be some difference. When it comes down to modifying, you do retain a lot of the original design. You can look at the bike wheel, just the history of the bike wheel, since we're running with the wheel analogy. And the bike wheel itself was modified quite a few times. We did different arrangements of spokes to try and make it work better. Actually, there was a point in which it was just a solid disk, if memory serves me. So we did modify the bike wheel. But if you look at the difference between the bike wheel and, say, an airplane landing wheel, the only thing they have in common is that they're round. They really don't have very much in common at all, because in that situation, we had to completely reinvent. We don't have the spokes in this situation. We have to deal with the axle still, but we needed to have a different kind of wheel with a different shape, different form for the tire, so that it could handle the impact of landing. And then if we go over to the moon lander, now we have a completely different wheel that's still, again, vastly different. It's much wider. It's got different tread. It can handle much different situations. So I think there's a subtle distinction between modifying and reinventing. When it comes down to code, we can modify a code library. Say there's, I guess the best example is my company's animation project. We initially intended to modify some existing code from a project called Synfig Studio, which is excellent, by the way. Go check them out if you want to learn how you can do really good animation on open source. Synfig's really cool. We had originally looked at modifying the synfig code, but the problem was that the basic logic that they were using would not have worked for what we were trying to do. We had to completely reimagine the logic, turn it totally upside down, take several things out, put new things in. And so it was so vastly different. Just the base logic was so vastly different than from synfig. It wasn't a modification. We were having to totally reinvent how animation was being handled by the system. So I do think there is a distinction between the two, and I think that's where we have the danger of the phrase, don't reinvent the wheel. We have to, as I said, know when to reinvent it. All right, so do we have any other questions here? I'll give everyone a second. And while I'm waiting, by the way, for any additional questions that might pop up, you can find more information about that animation project and what my company does at mousepawgames.com. You can also follow us on Twitter. Our Twitter handle is MousePaw Games, kind of handy. You can also follow me on Twitter. I post a lot of stuff, both programming related and otherwise. I tend to be a bit snarky. I don't know if you can tell. So my Twitter handle is Indelible Blue Pen. Just leave the E off of blue because I ran out of characters. So that's INDELIBLEBLU pen. I'll stick that in the description of the video as well. And you can check out my blog at indeliblebluepen.com. Leave the E on the blue that time. I've been running that blog for about 6 years now, and actually that's where most of my material for the speech comes from, is from my semi-random musings on Indelible Blue Pen. Okay, so I got another question here. Should we write pseudocode or flowcharts before we do any coding at all, or is it okay to write code first? Well, it's interesting because actually there's benefits to both methods. At my company, we have two different teams. One is very planning oriented. They plan everything to the nth degree. We have pages of documentation. Actually, that team spent about 2 months, 2 or 3 months planning before they wrote a line of code. And actually, they're the ones in charge of the animation system. In that situation, it's very important to do the planning in advance because of how complicated the animation system really is and how many pieces have to fit together right the first time. It's much easier in the animation system to plan in advance, get all the bugs worked out in the logic, and then code it, than to try and debug it after it's coded. On the flip side, however, we have another team that is in charge of the content engine. It loads the educational material in for the game, handles code, it handles, or not code, scores, levels, files, progress throughout the game. And they're also largely responsible for writing RATscript, our in-house programming language. With a few exceptions, for the most part, they tend to work by the adage of move fast and break things. They write code and they plan as they go. So they just figure out what they want to do and just start coding it. The benefit to that method is that the code gets done a lot faster and they're able to just think on their feet. They come up with ideas for features and methods as they go. So as they build one piece, to see how that works and then decide what to put on top of it. So there's benefits to both methods, and it really depends on what you're doing. This gets very close to the idea of methodologies. We have all these different methodologies in the world of computing. We've got Agile and extreme programming and Scrum and Waterfall and all this stuff. And there's proponents for each style. But the thing is that just because one project uses Agile and gets away with it, yes, I said that on purpose, or just because one project is able to use extreme programming and get good results, doesn't mean the next project will. There is no magic bullet. There's no one way to do it, either in code or in project management. So we have to approach the question of how do we handle this part of the project on a case-by-case basis. So at my company, we really do have a wide range of ways we handle different parts of the project, but it works pretty well for us, actually. Okay, so I'll wait again for any additional questions here. A little more film material here in case you're wondering how I'm running this, by the way, for the nerds out there. I'm actually running Ubuntu Linux here, so that allows me to have my LibreOffice Impress presentation up here, and I've got a little screencast program called Komoso down in the program, down in the corner. So I'm just screen sharing actually right now, and this actually works pretty well, I think. So yeah, I like Ubuntu. It's got a lot of really neat features. It's been using it for a few years now. All right. So again, if anyone watching has any questions that they want me to answer, once again, feel free to email me or contact me, jcmcdonald@mousepawgames.com. I'm happy to answer any questions you might have. And thanks for watching, and hope everyone has learned something today that's useful, and I hope to do this again sometime. So thanks for joining me, and have a fantastic day.